Thanks for joining us on this presentation introducing types of automotive window film. This quick presentation is built to introduce automotive window tinting film types, and as you know, with any introduction or summary of a view from 30,000 feet, there are certainly alternative ways to build this training. However, the hope is that within just a few minutes you'll be able to recognize some of the automotive film types by name or by group, and you'll have a framework upon which you can make reasonable comparisons and build into your next set of questions. This presentation takes about 13 minutes, so let's get started. As you consider the way or ways in which you can separate automotive window film types, there certainly are more than these, but let's discuss the way we're going to use, and that is based on construction. What are the components? What are the processes? How are window films built, created to be different? Now, certainly we could also separate on any of many various function differences. Some films have better heat rejection than others. We could separate based on significant heat rejection and insignificant heat rejection. We could separate films based on what we might call an older technology. It must be dark to block heat, and the function where you can have virtually clear films that still block a lot of heat. We could separate based on that functionality. We could also separate based on, well, these over here are 5 to 7 year warranties, and these over here are lifetime warranties or transferable warranties. What's the life expectancy of the product? The way we've chosen to do it, as we said, is based on construction. As we go forward, let's say it now, and let's say it again later, that these four categories that we've come up with, they're not intended to be value statements. They're not intended to be, well, this one's good and this one's bad and this one is a 1 and this one is a 2. They're just descriptions. Because we believe that every automotive film customer has needs that when those needs are satisfied, they got the right solution, even if that solution is one film versus another. So a product that you might rank as number 1 for one customer might be the least attractive to the next customer. So these are not values or rankings. These are just 4 different families or types of window film products. The first one is going to be categorized as dyed or colored films, and we're going to include in here all the treatments that don't improve heat rejection, and you'll see a little bit later about what that means and how we can make that claim. Now these dyed or these colored films can be dyed or colored in different ways, but we're going to bring them together in one category of dyed and colored films. The next one is going to be a group of films that some of the technical purists may not like being together because functionally they're very different, but in their construction they're very similar, and that is a metallized film or a true ceramic film. And we'll talk about this in terms of they're the same because of a technology called deposition. The third is going to be a category of films called HP, and manufacturers across the window film segment will call the same kind of construction HP, which stands for high performance. And the last group we're going to call IR films. We're going to include all the surface coatings that do improve heat rejection, but are not a deposited metal or true ceramic. So let's look at these dyed or colored films. The plastic that makes up the window film can be impregnated to its core with dyes and with colorants. Or you can take a clear plastic and you can laminate a layer on top of it that has a dye or a colorant in it. We're grouping those together as the same. These are non-performing coatings, and we'll show you why and where that category comes in a minute. But these by definition are changing the color, and they may change how much visible light gets through, how dark it is, but they don't have what we would call performing coatings like the other 3 categories. The next category, metallized or true ceramic films. Now these two categories, metallized and true ceramics, they're very different in performance and in appearance, but their construction, the way they're built, is very similar. They're built by depositing in a very complex physical way atoms or molecules onto the surface of the plastic film that makes up the window film. These ceramic and metallized atoms and molecules, they don't fade. They don't have a color impregnation associated with them that can fade. Metallized, as a unique property in this category, the metallized films can what's called demetallize. It's unusual in an automotive film, but they can demetallize, and what that means is the metal atom, say for example an aluminum atom that was deposited on this film, as it rusts, it makes aluminum oxides. Those are no longer shiny silver like the aluminum atom was, and you can start to see that color change. We've touched on this concept of non-performing additives, dyed and colored films. And what do we mean by non-performing additives? We don't mean that they don't look different. They're doing something. They're changing maybe the color, maybe how dark the film is. But if you track these three graphs, they illustrate in the gray a dyed film, and the other two have what we would consider performing additives in them. And what this shows is if you consider, and it is a fact, that the total solar energy is represented, about 44% of it is from the visible spectrum. So if you cut down all the visible light and nothing else, you'd get about 44% total solar energy rejected. Now these are actual data points, so it looks on this graph to be maybe 42%. But what you can see from this is across this family of dyed films, there is virtually no rejection of infrared, which would show up here as increasing total solar energy beyond 44%. So what these three graphs show, and you could put any family of window film products in the world on this graph, and the dyed or colored films would be near that gray line because they don't have the capability of significant reduction in total solar energy beyond just the visible light transmission. I know this graph looks a little complex, but hopefully it'll sear in your mind this idea that dyed films are below these others in their performance because they don't have performing additives. They have non-performing additives. So with those first two considered, the dyed or colored films and the metallized or true ceramic films, what about the last two, HP and IR? We mentioned HP is an abbreviation for high performance or high performing. It's an abbreviation used throughout the window film industry, and it almost always refers to a film construction that combines the first two. It combines a dyed or colored film with a metallized film. And so the layer in these multiple layer films, the layer that offers the performance is often a metallized layer. The layer that offers a darker film without being shinier is often a dyed layer. So if you consider the previous graph, an HP film has the limitations of having in it a portion of dyed film which has non-performing additives, and in addition with that it has a metallized film which has performing additives, so the performance will be better. The fourth construction consideration is an infrared film, and we're going to categorize infrared films. They're typically a liquid coating. Inside the coating has particles that absorb radiation in the infrared region. They're infrared absorbers. And these liquid coatings can be combined with other film types. So you coat a liquid with infrared absorbers, that's an IR film. Laminate it to a dyed film, it's still an IR film. Laminate it to a metallized film, it's still an IR film because it has in it this capability to absorb infrared. Now we mentioned before that we realized that we could slice and dice this a little differently. We've probably left out some extraneous product line, some product type that doesn't fit one of these four categories. But in these four categories that really make up the lion's share of all automotive window film products, what are the pros and cons? Why are there so many? Well, considering first dyed film. Dyed film is inexpensive and it's easy to shrink. So you can get it on the car fast, so you can get it on the car cheap. One of the cons, and I don't want to overstate this, but it is a fact, all dyed films will fade. Now some have a 5-year warranty, meaning they're going to fade quickly. Some have a lifetime warranty, meaning they're going to fade so little over so long a time you'll never notice it. But technically all dyed films will fade. Also, dyed films have low heat rejection, as you saw in the graph. Metal and ceramic films, again, they are very different in their appearance and their performance. But what are some of the pros and cons of metal and ceramic films? Well, first is you can get really high heat rejection. And there's no capability of fading metal and ceramics, although we mentioned the possibility of metals demetallizing. The cons, number one, they can be difficult to shrink. And metal films can have the appearance of being shiny. Some people don't like that. And metal films can have the possibility of interfering with a car's electronics. What about these HP films that combine dyed and metal films? Well, like the dyed film, they're relatively inexpensive, and actually some people like a little shiny look, so that would be a pro to an HP film. HP films that have dyes, again, all dyed films will fade. So you have to pay attention on a HP film with a dyed film layer. What's the warranty? Will it fade enough and fast enough to be a problem? And even though dyed films are a combination, HP films are a combination of dyed films and metal films, the metal film layer can at times be too shiny, just like a pure metal film, and it can at times interfere with electronics, so you need to be aware of that. What about these IR films as our fourth category, pros and cons? Well, the first is they're easier to shrink than a metal ceramic film. They'll be harder than a dyed film, but they're easier than a metal ceramic film. And yet you still get good heat rejection, unlike a dyed film. If you build into your IR films a dyed film layer, again, you have the potential for the fading of the dyed film layer. So if you have an IR film with a dyed layer, you have to make sure you understand is the warranty, is it in the 5-year range where it may fail in your lifetime and your use of the vehicle, or is it a lifetime warranty or even transferable lifetime warranty? Those dyed films are going to be very different. And lastly, the IR films, although easier than metal ceramic, as we said just a minute ago, they will be harder to shrink than a dyed film. If you have any questions for us, please don't hesitate to contact us at training@programedge.com. We sure appreciate your attention. Thanks.